Welcome to the SciComm machine learning tutorial. In this presentation, we demonstrate multiclass and multivariable classification using rich classifier. This model is regularized linear classifier that is well suited for high-dimensional datasets. We will walk through the entire pipeline from data processing to training and evaluation using a real-world heart disease prediction dataset. Here is an overview of the dataset's features. We have demographic and clinical indicators such as age, sex, and chest pain type, which includes categories like typical angina and asymptomatic. Physiological measurements include rest BP and cholesterol. Diagnostic indicators like resting ECG, max HR, exercise angina, old peak, and ST slope help capture cardiovascular performance. The target variable, heart disease, is binary. 1 indicates presence of the disease and 0 indicates absence. The target of our classification task is the heart disease column. It labels each patient as either having heart disease or not. Since this is a binary classification problem, rich classifier will learn to separate those two classes based on patterns in the clinical and demographic features. To prepare the dataset for training, we convert all categorical string variables to integer presentations. For instance, sex is mapped into 0 and 1, and categorical values in chest pain type, rest ECG, ST slope are also encoded numerically. This transformation allows the rich classifier to process the input features correctly since it requires numerical inputs. Rich classifier is a linear classification algorithm that extends rich regression to categorical targets by treating classification as a regression problem with L2 regularization. It minimizes the squared loss between the predicted and actual classes labels, while penalizing large coefficients using an L2 norm term to reduce overfitting and handle multicollinearity. This makes it well suited for high-dimensional datasets and cases where input features are correlated. Rich classifier supports both binary and multi-class classification tasks and offer a closed-form solution for fast training. It is particularly effective when interpretability, speed, and robustness are priorities in the classification pipeline. Once the features are prepared, we split the dataset, 80% for training and 20% for testing. The rich classifier is trained on the training set to learn linear decision boundaries. We then make predictions on the test set and evaluate the model using the F1 score, which balances precision and recall. Now, let's move to the SciComm machine learning website and use our ML AI tool to implement the classification problem. Here, let's first name our project, and then let's write a brief summary of our project. In the data section, let's choose our tabular data since our data is in CSV format. And then let's click this button to upload our dataset. Let's choose our dataset. After successfully uploading the dataset, we can see the overview of the dataset on the right side of our page. We have all the columns. And then if we want to have an overview of the data, we click the Data tab, and it's going to show us the data types, unique values, etc. Now let's choose our target label, which is the heart disease column. And then let's click the machine learning method, and let's choose our classifier. We use the rich classifier. And let's choose our evaluation metric here. We use F1 score. And then we click Perform to get our result. So after a few seconds, we can see the F1 weighted score is 0.9, which is a very good score. That means our model was able to have an accurate prediction. And if we want to see the predicted results, we can slide this bar to the right side, and then we have this y-test column and y-predict column. Y-test column is the ground truth of our dataset, and y-predict column is the predicted data. And this has been our tutorial for rich classifier. Thanks for watching.